Hello and welcome to today's video. In today's video, I want us to learn how to convert structural formulae to covalent bonding or covalent bonds. Now, this works on a very simple principle, and the principle is that a pair of electrons represents a single bond, or a single bond represents a pair of electrons. So anytime we see something like this, or we see cross and dot, or we see dot and dot, this can be a single bond. What does this mean? For example, if I have A bonded to B, this, according to covalent bonding, is the same as A dash dash B. So I have two electrons. If I have A double bond B, this, according to covalent bonding, means that A and B are sharing 4 electrons, because a pair of electrons represents a bond. Then, if I have A triple bond B, this basically entails that I have 6 electrons, 1, 2, 3, 4, 5, 6, existing between A and B. That's the first principle. The second principle is that you have to satisfy the octet or the duplet rule. So by octet we mean you should have 8 electrons in the last shell. By duplet it means we're supposed to have 2 electrons in the last shell. So let's look at examples. I'll give an example of H2O, which is water. So in terms of structural representation, water is presented like this. So if I change this to covalent bonding, it means that I have the oxygen in the middle with 2 electrons there. Then the outside overlaps with the hydrogen, So this means 2 electrons. So there is that sharing, that means 2 electrons. There is that sharing. So the oxygen is stable. The hydrogen is stable. It has satisfied the duplet because it has 2 electrons, but the oxygen in the middle is not stable because it's supposed to have 8 electrons. So that's why we have those lone pair electrons that will come out like that. So that is how we present water as from a structural to a covalent bonding. Let's look at another example. O2. So O2 is O double bond O. So what does this mean? So draw the structure of the oxygen like that. Then the other one will overlap like that. So this means a pair of 4 electrons. So could be 1, 2, 3, 4. Then you have to satisfy the octet to the duplet rule. So there are only 4, they're supposed to be 8. So there's a remainder of 1, 2, 3, 4, and the remainder of 1, 2, I have swapped 3, 4. So this is how we represent the structural formula of oxygen to a covalent bonding. Let's look at another example. a molecule of nitrogen is presented as N triple bond 3. So this means you have that nitrogen 1 2 and then another nitrogen 1 2. So triple bond, so this means 6 electrons. So 1 2 1 2 1 2. And then you have to satisfy the octet. So when you count, you have 6, meaning there's a remainder of 2, and then there's a remainder of 2. So like that, it's stable. Let's look at methane, CH4. So it's presented like this. So taking these to bonding, which is covalent bonding, means you have a carbon 1 2, and then this carbon is bonded to hydrogen, bonded to hydrogen, bonded to hydrogen. Then they will share the electrons like that. So that is how we change from structural to covalent. We can look at another example. Let's look at ethylene. This is H, C, triple bond, C, H. Changing this to covalent bonding, you can pause the video and give it a try. So this means you have a carbon and another carbon. So let me just show the outer electrons. So that is the hydrogen, and we have another hydrogen. So a pair and that, pair and that. Then in the middle we have 6 electrons. 1 2 3 4 5 6. So it's going to appear like that. Let's look at something even more complex. Let's say we have something like this, which is ethane, and then we want to change it to covalent bonding. So we have a carbon and another carbon. So I'm just going to show the outside. I will not show the inner electrons. So we have this, we have that, we have this, and we have that. So there they'll share pair of electron, pair of electron, pair of electron, a pair, pair, pair. So we're gonna have something like this. Let's look at example 7. Let's say we have these double bonds, and so this is called ethene. So changing this, it's just a matter of knowing that you have 4 electrons because it's 2 pairs. So we have a carbon bonded to that, then hydrogen there, hydrogen here, hydrogen here, hydrogen there. So it's a pair, and electron, a pair, electron. So that's a carbon, carbon. So we have 1 2 3 4 carbon. Yes, so we're gonna have something like that. 8. Let's look at something like this. So this is known as methanol. So converting this means you have a carbon bonded to, so there's hydrogen here, there's hydrogen there, there's hydrogen there, so this is a carbon. Then you have an oxygen atom. So I'm just drawing the outside. So there's a single bond there, so 1 2 1 2 1 2, sorry, 1 2. Now this is bonded to, there's another hydrogen here, which is just giving us 1 2. Now you realize that the carbon is stable, it's satisfying the octet, it has 8, the hydrogen has got, so this is the carbon, the hydrogen has got 2, but the oxygen is only having 4, so it means that you need to add extra 2 there to make it 8. And that is how we present methanol as a compound. Let's look at something more interesting. Let's say, for example, we have been given this CH2. So this is called cyclobutane. So how do we change this? So we have a carbon here bonded to another carbon, then there's another carbon bonded to, so it's interesting. This carbon is bonded to this and then it passes there. So you realize that it's gonna leave some space here. So there's no intersection. There's that space that is left. So we have 2 there, we have 2 in there, we have 2 in there, we have 2 in here. Then the rest are the hydrogens. So there's hydrogen, another hydrogen. So 1, 2, 1, 2. There's a hydrogen here, 1, 2, 1, 2. There's a hydrogen there, 1, 2. Another hydrogen, 1, 2. Then 1, 2 hydrogen, and another 1, 2 hydrogen. So it's gonna appear something like this. That is cyclobutane. So this is 8. You might want to look at ammonia. So ammonia appears like N, hydrogen, 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 then 2 lone pairs. So this only means that you have a nitrogen, then you have a hydrogen, hydrogen, and another hydrogen. So they'll share there, they'll share here, share there, then the remainder with the lone pair goes there. So that is ammonia. You can try out the 10th one. Let's say we have something like this: CH2, 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 CH2. So this is called cyclopentane. Yeah. So you can try this at your own convenient time. And let me also put this, very common. So this is coming from carbon dioxide. This is carbon dioxide. You can try those and you can send me the answers. Thanks for watching.